if I can change it. So I will use it that way. It's just a small presentation. And thank you very much for the introduction. My name is Gabriel Sansiglo. I'm a software developer at Brazil Data Cube project and HARMONIZE project. And I'm going to present the integration Earth observation data for enhanced health response system, the EODCtHRS component for the HARMONIZE project. Here's all the members of the HARMONIZE project. It's a broader project from Brazil Data Cube, so almost all of the developers from the Brazil Data Cube are here on the HARMONIZE project, and we have a few other members of the project from different institutions from Brazil and abroad. Before I start the HARMONIZE presentation, I would like to give a background on the Brazil Data Cube of what it is, because we have a core workshop from Brazil Data Cube, but we will not have a presentation, so it's good for give a little feedback, for little explanation for about what is it. The Brazil Data Cube project is a research and development project with the goal of producing analyze and visualization large volume of remote sensing data structured as image data cubes and RRD project, analysis ready data, from the entire Brazil territory. All the Brazil Data Cube is structured in following the STAC API, the STAC structure, to STAC technology all by itself. And overview from the HARMONIZE instance, the HARMONIZE Brazil, which I will present. It's a technical concept developed based on the Brazil Data Cube and other demands for health insurance data analyzed. It's a compromise to integrate multiple fronts. So here's an overview from the HARMONIZE structure instance. So we have a front end, a back end, a developing interface, and all the workflow to producing new harmonized data. So the health data, climate data, remote sensor data, and drone image collection data. Here is our 6 models that compose the HARMONIZE instance, such as drone data, health data, climate data, the Brazil Data Cube Laboratory, the HARMONIZE Explorer, and EODCtHRS. I will present briefly each of one of them. The first model, called drone data, it's a model created to produce image collections in structures in STAC based on projects that already have been made at the National Research Space Institute Brazilian, the INPE. So the summarize of the process is we get all the fieldwork data from the campaigns with the auxiliary geo informations. We process it on our servers to produce geospatial data and use this geospatial data to build image mosaics to easily visualization and build image collections. All of them cataloged using STAC and then stored in our metadata database, and then available at the data visualization and analysis platform, the HARMONIZE Explorer. Here's another view of our process. We get the data from image data. We have the interface Python program, so we can process all the data. It's called EODCtHRS image processing algorithm. And we have the output data as drone image processed using COG. We also have a third-party application based on open drone maps. Here's an example of one of our latest projects from drone data. In 2022, we have 46 flights, over 15 gigabytes of raw data. And in 2023, we have 23 flights, so over 1,600 gigabytes of data. And the expected size from 2014 14, no, 24, it's over 1 terabyte of data because we starting to getting multispectral drone images. Here's a HARMONIZE Explorer plotting where and how many images we have collections from drone data. The presentation is not good to see, but there is points where you can zoom in and see how many data we have on that point. Here's an image mosaic from our campaign in Altamira, if I forgot to write. So we have drone data with visualization on the HARMONIZE Explorer web portal. Here's also other mosaic from Bairro Novo, here on the state of Pará. Another data model that is integrated on the HARMONIZE Explorer is the health data. We have a connection with the PTEC and the Laboratory of Information and Health from INPE. So we developed for the health data an integrated and dissemination flow. So we have the data sources, processing, and then publishing, all using Python and PostGIS. For the data, we use the GeoServer to publish the data for the web portal. All the packages used for processing drone data, health data, and climate data I will present later are on the GitHub of the project. So here is the EODCtHRS health indicator processing package. It's all based on Python. So we have the input data in Parquet. We use the Python package interface to process it, and the output in vector or images. Here's an example of the healthy data on the portal from dengue alerts in the municipality of, I forgot the name of municipality, sorry. Here's another, the healthy data alert on the platform. Here's chikungunya notified case, monthly cases summarized, if I've forgotten, if I remember right. Visualizing on the HARMONIZE Explorer portal. Here's the climate model. The climate model was developed based on the ERAS land data, CPTEC data, and other climate sources. We process the data requests from our data source. We use the EODCtHRS R package for climate processing. We share the spatial data using shapefile, using GeoServer and JSON file, catalog in STAC, and then service the data using a Python or a package based on the APIs we have developed. The two web front interfaces are the BDC-Lab, I will present later, and the HARMONIZE Explorer. The package of the EODCtHRS climate processing data is available also on GitHub. It's a R package, so any user can get from our raw data as netdf, TIFF, or shapefile, and process it and output it as COG or shapefile for your own interface or own personal use. Here's a climate data visualization on the portal. So we have temperature and max temperature for the Pará, especially our study region. So any of the following cities have different temperature can be visualized and use the portal with the time-based navigation. Here's another data of climate data visualization on the portal is a precipitation data mean for another study area with time visualization using the timeline. Here's another data, relative humidity data. And the fourth model I want to present is the Brazil Data Cube Lab. It's been developed since 2021. It's a Jupyter-based web platform, so the user can process their data on the server side, not on their own machines. So the goal was to build a tutorial on how users can access drone data, health data, climate data, and perform analysis on the cloud, not in its own platform, its own computer. The Brazil Data Science Lab, the BDC-Lab, was developed using Kubernetes, so we deploy a machine with the specific configurations based on the user requests, and then the user has its own interface with its own storage, memory, CPU, so the user can process their data on the cloud and let it be processing while doing other things on its own machine. It's all based on, with authentication based on the system Keycloak, open source system for authentication. And we have data sources already connected, such as Brazil Data Cube, CPTEC, HARMONIZE, DataSUS. And we have packages, data science packages such as SEEDS, Geoplot.lib, NumPy, Matplotlib, Pandas, and others. Ever since May, we have been developing new versions from the platform. I'm not going to list each of the new features, but I would like to point out that a lot of institutions and from Brazil have been using the Brazil Data Cube Lab and been producing data inside of it. So it has been, in this past 4 years, been a very much used platforms from different laboratories from the Brazilian National Space Research Institute and others such as IBGE, Embrapa, and others projects and institutions research from Brazil. The Brazil Data Cube Lab is based on the Jupyter Notebook, so it has the same interface of the Brazil Notebook, but we have such as new features integrated, such as a web app, so you can use QGIS inside of it. We have a web browser inside of it, so we can download the data. We have our studio and other applications inside of the Brazil Data Cube Lab. Another model that's developed by me, it's the HARMONIZE Explorer, a web portal for the EODCtHRS component. It provides a visualization of the features produced by the project, such as data cubes, drone images collections, health data, climate data, and drone mosaics. Here's a screenshot from the platform. You have the data products on the left, you have the map on the right, and you can perform web searches from each of the type of data you want. Here we have data cubes, image collections, climate data, health data, and mosaics. The drone data is inside the image collections, but we also will have new image collections that beyond drone data. Here's a screenshot of a drone mosaic visualizing being on the platform. So we have the timeline on the top, we have the drone image with the portal navigation on the center, and the web search on the right. User can perform searches and download each of the data they want from their respective area, so you can search what data the platform have on the specific region, and then fetch all the data available based on STAC. The sixth and the last model is the Earth observation data cubes. Ever since the start of the project, beyond the drone data, climate data, and health data, we had the Earth observation data cubes. We have 3 countries partnership, the República Dominicana, and Peru, and Colombia. So we have developing satellite image data cubes for their region. Here's an example. We produce a data cube for 1 year based on Sentinel-2 and Landsat. Here is an example for data cube products from the República Dominicana. It was downloaded with ESA. We have visualization over the Data Cube Explorer platform. Here's an example. We have data for all the country with a cover of 1 year. It was an example we did to promote the production of EU data cubes for different countries. Here is an example of the web platform DataCube Explorer. HARMONIZE Explorer with DataCube from República Dominicana. We have the timeline, so it's over 1 year of data, and each of the features available from there for this DataCube. Here's an example of a zoom in on the north of the island. And that's it. I have to move fast because it's a lot of things I have to show, but I would like to answer any question that any one of you have.